In the previous lesson, you learned how to determine the empirical formula for a compound. Now, the important thing for you to know about empirical formulas versus what we're going to learn about today, molecular formulas, is that the empirical formula, which is the lowest whole number ratio, the empirical formula only shows you the relationship quantitatively between atoms. So for example, all this is showing you, this formula right here, is that for every one carbon atom, there are 2 hydrogens and 1 oxygen. All right, so for a lot of compounds, the empirical formula will not actually be the correct formula, the true formula that represents what a compound is made up of. Instead, for example, this is the true formula for glucose. This is the empirical formula, this is the empirical, this is the molecular. Molecular is the true formula. Now, what we're going to learn today is how to actually determine the molecular formula if you know the empirical formula. So if you look at this formula right here, it says N equals molar mass divided by empirical formula of molar mass. N represents an integer, a whole number. And you're going to take the empirical formula and multiply each of its subscripts by that integer. So if you notice here, to go from this empirical formula to this molecular formula, you should be able to tell that the integer N for this is 6. Because to go from here to here, you need to multiply by 6, here to here, multiply by 6, here to here, multiply by 6. So that is the integer for glucose going from its empirical formula to its molecular formula. Now I'm going to show you how to actually determine the N, the integer, so that you can then find the molecular formula of CH3O. So I'm going to write this out right here. N equals, the integer equals, the molar mass, that's the molar mass of the entire molecular formula, to which you might say, well, I don't know what my molecular formula is, but good news, this value, the molar mass of the molecular formula, has to be given to you in order for you to calculate the molecular formula. So molar mass is 62, and you're going to divide that by the molar mass of your empirical formula. Now, the molar mass of your empirical formula, carbon has an average atomic mass of 12.01 plus the average atomic mass of hydrogen, which is 1.01, times 3, because there are 3 hydrogens, plus the average atomic mass of oxygen, which is 16. So if you do that, 12.01 plus 1.01 times 3 plus 16, you end up with 31.04 grams per mole. And so I'm going to plug this value in right here because that is the molar mass of my empirical formula. So you end up with 31.04. When I divide, I end up with 2. That is my integer. Okay. So now all you have to do is you have to take your empirical formula and multiply all the subscripts by that integer. So this would become C2, because there's an implied 1 right there, H6, and then O2. So this is your molecular formula. This is how it exists in the real world. This is the empirical formula, which simply shows you that for every 1 carbon, there are 3 hydrogens and 1 oxygen. What the molecular formula is showing you is that in this compound, there are 2 carbons, 6 hydrogens, and 2 oxygens. So that's how you determine the molecular formula if you are given the empirical formula.